Okay, we're going to continue with try number 2. Let's see if you can do it by yourself and come back when you're ready for answers. So you do have to use the distance formula using the coordinate points, and you need to figure out if they are isosceles, scalene, or equilateral triangle for triangle PQR. Okay, so pause the video and solve it first by yourself and come back when you're ready to check answers. Okay, are you ready? So first, what is the first step that you need to do? So 2A, triangle PQR. Is triangle PQR equilateral, isosceles, or scalene? Given the coordinate points P 4,1, Q 2,7, and R 8,5. First of all, you want to graph it and look at it visually, and that's going to make a triangle. You see that? You want to figure out the distance between the 2 points for each of them, each of the sides. So use the points one by one and figure out PQ, QR, and RP. So first, we need to compare their lengths. So first, we want to find PQ, which is going to be square root of the differences of x squared plus differences of y, but you need to start with the same point, 4, 1, 2, 7. If you started with 2, 7, 2 minus 4 squared plus 7 minus 1 squared also works. Okay, just make sure the orders are same. And let's set it up first. QR will be square root of, looking at your points, 8 minus 2, so now I'm going to do R minus Q. So 8 minus 2 square plus 5 minus 7 square. And then RP, distance RP, is going to be 4 minus 8 square plus 1 minus 5 square. Okay, and that's going to be 2 square 4 plus negative 6 square is 36. And this one, that's 8 minus 2, 6. 6 square is 36 plus 5 minus 7 is negative 2. Square that is 4. And then 4 minus 8 is negative 4. Square that, 16. 1 minus 5 is negative 4. Square that, 16. So that is 40, square root 40, and that is square root 40 as well, and that is square root 32. Okay. Can you simplify them? You can. Let's see. So divide 40, you have 20 and then 10. So that's really 2 square root 10, 2 square root 10, divide 32, 8 and then 2, 4 and then 2, 2. So 1, 2. So that is 2 times 2, 4 square root 2. Okay. But if you look at square root 40, and square root 32, you know PQ and QR are going to be equal. And RP is obviously not equal to the other distances. So we can say it is isosceles. Explain, because PQ is equal to QR, which is 2 square root 10, and PR is equal to 4 square root 2. Okay? Part B is triangle PQR a right triangle? Explain. So looking at your graph, this may be a possible right angle. That doesn't seem like it, but you should still check. This one just looks like an acute angle, but we can check what is possibly right angle. So let's check what is 27. QRP. So we want to check angle R. Okay. So first of all, we want to figure out the slope for this one. And we want to figure out the slope for that one. So QR, slope of QR, and slope of RP. Slope of QR and slope of RP. Figure it out. So the slope equation is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So plug in your y values. Make sure your points, the order of the points are the same. So QR, we can start with R. That's y. So 5 is your y value, minus 7. And then 8 minus 2. That is minus 2 over 6, which is negative 1 over 3. Let's check RP. RP is going to be 1 minus 5 over 4 minus 8. So that's going to be negative 4 over negative 4, which is negative 1. So are they opposite reciprocals, or do they multiply to negative 1? No. So they are not perpendicular slopes. Okay. Wait, that's positive 1. Never mind. But still, it's not a perpendicular slope. So this is, if you check all the other slopes, you'll see that none of them. So check the other slope. Slope of what's the other line that we need? PQ? Yeah. Slope of PQ is equal to 7 minus 1 over 2 minus 4, which is 6 over negative 2, which is negative 3. So none of them are opposite reciprocals. So these two are pretty close, but they are not opposite, right? They are reciprocals, but they're not opposites. So they still are not perpendicular to each other. So it's not, no, because there is no parasites with slopes having a product of negative 1. So here we go, write this down. There's no parasites with slopes that are opposite reciprocals or slopes having a product of negative 1. That was the answer for try number 2A and B. Please check your answers and see if you got it correctly, or see if you were on track to the right path. Let's look at example 3. Classify a parallelogram on the coordinate plane. What type of parallelogram is RSTU? Now we want to see and categorize parallelograms. We already know the different types of parallelograms. Now it's on a coordinate plane, and we want to check their slopes and lengths so that we can see if the sides are the same, or if any of the angles are going to be perpendicular or the same. So first, we want to determine whether it's a rhombus, a rectangle, or a square. So we're going to calculate ST and SR to check if the distances are the same. They obviously don't look the same, but you need to be able to prove it with coordinate geometry. So use coordinates in Algebra 1. So ST, use the distance formula. So differences of x plus differences of y values, square root is going to be our distance. So ST is square root of 52. RS is square root of 10. Since not all side lengths are equal, RSTU is not a rhombus or a square. And we know this is a parallelogram, so we know these the side lengths for these two for the parallel sides are going to be congruent. So we don't have to check one by one and calculate one by one. As long as we figure out one side for each pair of parallel sides, then that's good enough. And then we can say not all side lengths are equal. So it is not a rhombus. It can't be a square either. So see if this could be a rectangle, if the angles are perpendicular. So find the slope of the lines as well. We know that the opposite angles for parallelograms should be equal to each other. So if we figure this out and this out, we'll have a hint, right? And also, in order to be a rectangle, all angles have to be 90 degrees. So if you just check one angle, that should be enough. If that is not a 90-degree angle, it cannot be a rectangle. Okay, so check for right angles by finding the slopes. Slope of ST using the slope formula. 4 minus 8 over 8 minus 2 is equal to negative 2 over 3. Slope of RS is 8 minus 5 over 2 minus 1, which is 3. And are they opposite reciprocals? Well, opposite reciprocal of 3 is negative 1 over 3. And opposite reciprocal of negative 2 over 3 is positive 3 over 2. So and if you check the product of them, it is not negative 1, it is negative 2. So it is not a right angle, it is just any angle that is not a right angle. Okay, so they are not perpendicular, this cannot be a rectangle. So RSTU is a parallelogram, but it's neither a square nor a rhombus nor a rectangle. Okay, so you're going to use the same equations, the distance formula and the slope equation to figure out some information to see if they are any of them. So let's look at try number 3. The vertices of a parallelogram are A, negative 2, 2, B, 4, 6, C, 6, 3, and D, 0, negative 1. So now we want to check if ABCD is a rhombus or a rectangle. And if it's both rhombus and a rectangle, we know it's a square. But let's see if it is any of them. Okay? So pause the video and see if you can solve it by yourself using the distance formula and the slope equation, and come back when you're ready for answers. Okay, are you ready? So first of all, how do you check if it's a rhombus? By definition, rhombus is a parallelogram that has equal sides for all the sides. So all sides are equal. We want to figure out the distances between all the points. So let's figure out, since ABCD is going to be a parallelogram, we can just check consecutive sides. So 2 consecutive sides. We don't have to check all the distances. We just need to calculate 2. So let's do A, B, and B, C because they're consecutive. Okay. So first of all, we want to figure out if A, B, and B, C are congruent. So A, B, using the distance formula, negative. So let's do 4 minus negative 2 squared plus 6 minus 2 squared, which is equal to 4 plus 2 squared, which is 6 squared, 36. And 6 minus 2 is 4. Square is 16. That is square root of 52. And then BC, use the coordinates. 4 minus 6 square plus 6 minus 3 square is equal to negative 2 squared is 4, 3 squared is 9, which is square root 13. Okay? Are they equal? No, they're not. Right? So, no. It is not a rhombus because AB is equal to 2 root 13. So that could be simplified to 2 root 13. And BC is equal to square root 13. So two sides of the parallelogram are not, oh, let's move the screen up, right? Not congruent. Okay. Part B, is ABCD a rectangle? Explain. So in order to see if they're a rectangle, you want to figure out some slopes, right? So let's figure out the slope of AB and BC as a representative. So slope of AB is going to be 6 minus 2 over 4 minus negative 2, which is 4 over 6. So that's 2 over 3, okay? Slope of BC is going to be y first, right? 3 minus 6 over 6 minus 4, which is negative 3 over 2. So, yeah. So, they are opposite reciprocals. If you multiply them, they will be a product of negative 1. So, they are perpendicular. So, the slopes are perpendicular. So, part B, it is a rectangle. Yes. Slope of AB times slope of BC is equal to 2 over 3 times negative 3 over 2, which is equal to negative 1. So an angle of the parallelogram is a right angle, and if one angle is right angle, because it is a parallelogram, all angles are right angles. Okay, so it is a rectangle. All right, that was chart number 3. Let's look at example 4. Classify quadrilaterals as trapezoids and kites on the coordinate plane. Part A, is ABCD a trapezoid? So first you need to remember the properties of trapezoid. The trapezoid has one pair of parallel sides, but the bases are different, but the sides that are not parallel must be congruent. Okay? So a trapezoid has exactly one pair of parallel sides. Use the slope formula to determine if only one pair of opposite sides is parallel. So figure out all the slopes in this case, and then see if there's any slope that are opposite reciprocals, or they're the same, not opposite reciprocal. That's for perpendicular slope. In order to be parallel, the slopes must be equal to each other. Okay, so you see 1 over 2 here, 1 over 2 here. Slope of BC and AD are parallel. Okay, these are parallel. So since only the slopes of BC and AD are equal, line BC is parallel to line AD, and only one pair of opposite sides is parallel. Therefore, quadrilateral ABCD is a trapezoid. Okay, so for trapezoid, you just need to check the slopes. Let's see how could we check a kite? Is JKLM a kite? A kite has two pairs of consecutive congruent sides. Okay, so they're consecutive, they're together. The congruent sides are consecutive, they're touching each other. Okay, And no opposite sides are congruent. No, the opposite sides are not congruent. It's the consecutive sides. So you're going to use the distance formula to find the lengths of the sides and figure out all the distances. Okay? And then if you see consecutive sides that are equal, so JK is 5, MJ is 5, JK is here. Okay, that's 5. MJ is here, that's 5. Okay, so those two are equal to each other and they're consecutive. KL is square root 10, LM is square root 10, and they are consecutive and they're congruent. So since both pairs are consecutive sides are congruent to each other, and no opposite pair is congruent, JKLM is a kite. Okay, so for kite, you need to check all the distances and look for same distance as that are consecutive sides. Okay, so let's look at try number 4 and figure out the slopes and distances to check if it is a kite, trapezoid, or neither. Pause the video and come back when you're ready for answers. Okay, are you ready? So first of all, figure out all the slopes, figure out all the distances, and see if you see any common slopes or distances. So let's figure out slopes. That is a strictly vertical line, and that is an undefined slope. So the slope for that one is 0. So let's just label the easy slopes. Slope of QP is undefined. Slope of PS is 0. Okay? And now, slope of QR and slope of RS is going to be 6 minus 5 over 7 minus 2. That's 1 over 5. RS, 6 minus 1 over 7 minus 6. That is 5 over 1. So that's 5. Okay? So, what are we looking for a trapezoid? We want the same slope. We need one pair parallel sides. Is there any slopes that are the same? No. So this is not a trapezoid. Not trapezoid. Okay? And then while we're doing slopes, let's check the slopes for part B. Okay? So let's figure out slope of x, w, x, y, z, right? So wx and xy and yz and zw. Okay? So wx, 7 minus 2 over 4 minus 2 is going to be 5 over 2. So it's 5 over 2. xy, 5 minus 7 over 7 minus 4, negative 2 over 3. So negative 2 over 3. yz, 1 minus 5 over 4 minus 7. That's going to be negative 4 over negative 3. So that's positive 4 over 3. And zw, slope of zw, 2 minus 1 over 2 minus 4. That's 1 over negative 2. So it's negative 1 over 2. Do you see any same slopes? Nope. So this is not a trapezoid either. Okay. So what about, let's check if any of them are kite. Is a kite. So we're going to figure out the distances between all of them. So let's see let's figure out the distances one by one. QRST. So QR, RS, we want to figure out SP and PQ. And also we want to figure out XY, YZ, and ZW. Wait, XY and WX. Okay? And so QR, square root of 2 minus 7. 2 minus 7 is negative 5 square, plus 5 minus 6 is negative 1 square, which is equal to 25 plus 1 square, 26. RS is going to be 7 minus 6. Wait, RS. So, yeah, it doesn't matter which one you choose first. So 7 minus 6, 1 square, plus 6 minus 1, 5 square, as long as you have the orders right. So 1 plus 25, that's also square root 26. Oh. And then, let's see, SP. So that's square root 26, square root 26. And that's consecutive. Those are consecutive sides that are equal, so we're getting close. And if we just count the units here by graph, that's also fine because they're strictly vertical and horizontal lines, right? So 1, 2, 3, 4. 4 units. 4 units. 4 units as well. 1, 2, 3, 4. So they're equal and they're equal, and they're consecutive sides that are equal, and no opposite sides are equal to each other, right? So this is a kite. Okay, and then let's check the distances for WX, Y, Z. So WX will be square root of 4 minus 2 square plus 7 minus 2 square, and that is 2 square 4 plus 5 square 25, so 20 square 29. Square XY, 7 minus 4 is 3, square is 9, and then 5 minus 7 is negative 2, and then square that is 4, so that's square root 13. Square YZ, 7 minus 4, 3 square is 9, 5 minus 1, 4 square is 16, and so square root of 25, which is just 5. And then ZW is square root of 2 square is 4, square root of 1 minus 2, negative 1 square is 1, so square root of 5. So these are all different distances, right? Square root 29, square root 13, 5, and square root 5. And they're all different. So it is not a kite either. So it's neither. Okay, so those are the answers and the steps for figuring it out for try number 4, A and B. Okay, let's look at example 5, application part. We're going to find perimeter and area in a real world example. Dylan draws up a plan to fence in a yard for his chickens. The distance between grid lines is 1 foot. So 1 unit is equal to 1 foot in real life. Okay. So part A is 30 feet of fencing enough to enclose the yard. So the triangle represents the yard, right? That's his plan to fence in this yard. Okay. So is 30 feet enough to enclose, which means to cover everything? So basically they're asking for perimeter. And if you figure out the perimeter, that's going to be in units. And you need to convert that to feet, because 1 unit is equal to 1 foot, which means whatever perimeter you get in unit will equal to the same exact number in feet. So let's figure out the perimeter. You're going to find the lengths of the sides using the coordinate points. And you already know how to do that using the distance formula. And so AB turns out to be 10. BC turns out to be 10 as well. AC turns out to be square root 80. So if you add them all up, you'll get 20 plus square root 80, which is about 28.9. And 30 feet of fencing should be enough then, right? So perimeter is less than the 30 feet of fencing, so he has enough fencing material. Just about exact amount, I would say. Part B, for a healthy flock, each chicken needs at least 8 square feet of space. What is the maximum number of chickens Dylan can put in the yard? So we wanna keep the rule of having 8 square feet. So whenever you see square feet, square units, you're gonna think that is talking about the area, okay? Just in feet would be just one side, one dimension, okay? So 8 square feet means whatever your square is, the area is 8 square feet, okay? So your sides are going to be square root 8 each. So first, we want to see how many 8 square feet would fit in here. But in order to do that, we want to figure out the area of the area that's covered by the fence, right? So the yard, first of all, is an isosceles triangle since we have 2 sides that are equal to each other. So to find the area, we need the height of the triangle, and that could be BX, where X is the midpoint on line AC. Because if that's an isosceles triangle, then this is going to be, AC is going to be your base. So we want to figure out the midpoint that is on line AC. Okay, so figure out the midpoint using the midpoint formula, which is x of 1 plus x of 2 divided by 2. Add the x values together, divide by 2. Add the y values together, divide by 2. And that's going to be 6, 4. Right? 2 plus 10 divided by 2, 6. 6 plus 2, 8 divided by 2 is 4. So this is the midpoint of AC, 6, 4. And then what do? We want to find the height, which means we already have the coordinate point for B and X. So we're gonna figure out using the distance formula. So plug in your points into the distance formula. You're gonna get square root of 80. Then you're gonna find the area of the yard because the height is square root 80. Your base can also be figured out using the distance formula, but you've already figured it out in part A. So AC is going to be square root 80. Square root 80 and BX, they're the same, right? The height and the base are congruent. So you just multiply base times height divided by 2, and that's the area of the triangle. And base and height are the same. Square root 80 times square root 80 is 80. Divided by 2 is 40 square feet. So that is the area of the triangle inside the fence. So you're going to divide 40 by 8 to see how many 8 square feet of an area would fit into this area. So 40 divided by 8 is exactly 5. So we can say that Dylan can keep as many as 5 chickens in the yard. Okay? So it depends on what kind of information we want to get. We might not have to deal with slopes. Slopes are to see if any of the angles are parallel or perpendicular to each other. So when we're looking at angles, then we use slopes. When we're looking at distances, areas, or dimensions, then we can use distance formula to figure out the distances between 2 points on a coordinate plane. Okay, so let's look at try number 5. There is a given information of the vertices, so the coordinate points are given. We want to figure out the perimeter of WXYZ and the area of WXYZ. It is a quadrilateral, so in order to figure out perimeter, you need to get 4 sides and make sure you know which is the length and which is the width of the quadrilateral, and you can use the area equation. For if it's a rectangle, you can simply just multiply base times height. But if it's not a rectangle, and you have different angles, or if it's slanted, right? It's a parallelogram that is not a rectangle, then you need to figure out the height. And then multiply base times height. Okay? So it could be length times width or base times height. All right, so let's pause the video and see if you can solve it by yourself. Come back when you're ready for answers. Okay, are you ready? So in order to figure out the perimeter, you need to know the lengths of all sides. Let's figure out the lengths for WX, XY, YZ, and ZW. Okay, use the distance formula. WX is going to be 5 minus 2 squared plus 4 minus 9 squared. XY is going to be 2 minus 9 squared plus 9 minus 9 squared. YZ, 8 minus 9 squared, 4 minus 9 squared, and ZW, 5 minus 8 squared plus 4 minus 4 squared. And so simplify them. 5 minus 2 is 3, square is 9. 4 minus 9 is 5, negative 5. Square that is 25. So that's square root 34. Then 2 minus 9, negative 7. Square is 49. 9 minus 9 is 0, so you just add 0. 8 minus 9 is negative 1. Square is 1. 4 minus 9 is equal to negative 5. Square that is 25. So square root 26. Then 5 minus 8, negative 3. Square that, 9. And then you add 0. So square root 49 and square root 9, which is just 3. Okay. If you add them all up. Oh, square root 49 can be simplified to 7, right? 7 squared is 49. So if you add them all up, you can add 7 and 3 together. So perimeter is equal to square root 34 plus 7 plus square root 26 plus 3, which is equal to square root 34 plus square root 26 plus 10. And you can't simplify any further, so you can just write that down, okay? Square root 26 plus square root 34 plus 10. All right, what is the area of WXYZ? If you graph this, I'm gonna graph the points. you want to just see the shape of them. So you see some of the same x values and same y values, and you wonder, is this going to be a rectangle? Is this going to be a parallelogram? Do I need to figure out the height? Oh, this looks closer to trapezoid, right? In that case, you have to use the trapezoid equation where you do base plus that base, another base divided by 2 times height. So in this case, because your y values are the same, right? We have the y values as 4 and y values of 9. We can literally count the height in units. So the difference between 9 and 4 should be 9 minus 4, which is 5. So the height should be 5. This grid line, okay, that is more accurate. So if you count this, 1, 2, 3, 4, 5, that's 5 units, and that's the height. Using the trapezoid, the area of the trapezoid, you have to figure out the distance of these two bases. So then figure out the distance between distances of wx and wx and yz. So let's do that. So that's our plan. Figure out the distance of, so height is 5 units. And then we need to figure out wx and yz. But we already know the distances, right? So we're going to use square root 34 and square root 26. And then use the area of the trapezoid rule. We're going to add square root 34 to square root 26, divided in half, and then times that by 5. Okay, I think I mixed up the coordinate points, so that is not W. The purple point is W, right? So that's W, X, Y, Z, which means that's W, X, Y, Z. So we want to figure out X, Y, and W, Z, which happen to be a nice little whole number. So we don't need that. Let's erase that. We need X, Y, and W, Z, right? So X, Y is 7. ZW is 3. So then we can just use our nice little whole numbers instead of the square roots to figure out areas. So 7 plus 3 divided by 2 times 5 would be our area. So 7 plus 3 is 10 divided by 2 times 5, which is 5 times 5, which is 25. So the area is 25 square units. There we go. So those are the answers for our try number 5A and B. So they look like they are going to take a lot of time, but if you get used to the distance formula and the slope equations, you'll be able to figure out the word problems easily if you are able to gather the information correctly. So let's summarize our lesson, connecting algebra and geometry. This is where the connection happens. You can use algebra to determine properties and to classify geometric figures on the coordinate plane. You can use distance formula to find the lengths of segments and classify figures. You can use the slope formula to determine whether two lines or segments are parallel or perpendicular. You can use the midpoint formula to determine if a point bisects a segment. So remember that these the formulas, so let me state that again. Distance formula, D is equal to square root x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, the difference is. The slope formula, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you might wonder again, what are x sub 2, y sub 2? If you have two different points, and we're going to label one point as x sub 1 and y sub 1 so that we can distinguish them, okay? And then x sub 2 and y sub 2. So we're saying the order does matter. If we're starting from the second point, we need to subtract the first point from the second point. We can't mix that order up, okay, in one equation. Midpoint formula is equal to x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. Okay? Alright, that was lesson 9-1, polygons in the coordinate plane. And in the next lesson, we'll be able to use more geometry and reasoning to figure out and reason out a proof. We'll deal with more proofs later, but we just started a topic with a lot of algebra. So this should be a review on the algebra concepts that we're going to use in the future. All right, if you have any more questions, feel free to ask me in class. Otherwise, we'll continue the next lesson in the next video. Thanks. Bye.